Hi, today I'm going to talk about carboxylic acids. I'm going to mention some properties of them and interesting facts about them. Carboxylic acids, as I mentioned before, have many physical properties, one of them being their boiling point and their melting point. They have high boiling points, being the lowest 101 Celsius degrees and the highest going up to 253 Celsius degrees. Then we have the melting point. The melting point in these acids has less range than the boiling point, being the highest 8 Celsius degrees and the lowest minus 34.5 Celsius degrees. Something very interesting in these acids is that they can change to liquid and solid depending on the amount of the acid. If there is a small amount of acid in a room temperature environment, it will be a liquid. And if you have a higher amount of that acid in the same room temperature, it will stay as a solid. The carboxylic acid has many derivatives. Some of these are more reactive than others. We can tell that the carboxylate group is the less reactive of them all. But, on the other hand, the carboxylic acids in general have good reactivity, one of these being with salt and water. The acids are not malleable as they are more molecular than metallic, and they are also typically not flammable. So they can decompose when heated and release flammable gases. There are two groups, the carbonyl and the hydroxyl, and these two have a rule. Well, not necessarily a rule, but a way to write them. The functional group of carboxylic acids is the carboxyl group. And now I'm going to show a photo of the two groups, so I'm going to explain better. In the image, we can see the representation of what will be a carboxylic acid in a 3D and in a Lewis dot symbol structure. R is a variable group representing a hydrocarbon chain and hydrogen atom. The part that has the carbon and the OOH with the double bonding is the part more important because it's when we can determine if it's a carbonyl and a hydroxyl. The carbonyl has a carbon and a connection of with two bonding O and an OH. The hydroxyl has 3 OHs. To name these acids, there are 4 typical steps you need to follow. The first step is identifying the largest chains of carbon. This is easy, just only to count the largest amount of carbons that are together. Then we need to replace the E, while naming it, of an alkane with oic acid. So if it's like a nonane or a pentane, you're going to replace the E of the end with pentanoic acid. Then the chain will be numbered by the carboxyl acid. This will normally be on the right side of the compound. And for the last, you will use the prefixes of the number being but, penta, hepta, and that before naming it so we can know which number it is. Some important fact that you need to know about carboxylic acids is that they come mainly for nature. Their main uses are for food industry like vinegar, pharmaceutical purposes, and manufacturing. The fatty acid is one of acylic acid, is used to make soaps. Now I'm going to leave 2 examples of carboxylic acids, being acetic, an example of this. This is a clear liquid with a sharp vinegar-like smell. And then we have the citric acid. This could be found in any citric fruit like lemons. Well, I hope you enjoyed this video about carboxylic acids and you learned a lot.